Hello, everyone. Welcome to the SignPoint's More is Possible event. My name is Julio Calles Guzman, and I am the Application Engineer Training Lead here at the SignPoint. We are excited to have you here with us, and I have Sashi from Dassault Systems who's going to be talking to us about some functionalities of simulation. So, Sashi, take it away.
Thanks, Julio. It's really great to be here at the More is Possible Design Point event. So for today, for this session, we're going to talk about introducing simulation and collaboration on the 3D Experience platform. So to introduce this topic, we're actually going to look at this model. So this is the BIMI, which is a compatible handheld projector, which involves a lot of different components of different parts. So let's take a quick look at what's inside. So when we look at a product like this, it looks so simple on the outside, but then on the inside, there's so many different components, such as the battery, the PCB board, the main base, the chassis, the lighting, right? All of this has to come together to be able to produce a product like this. And from an engineering perspective, it typically involves a lot of different teams, right? Having to work together to come up with a product like this. And this is very, very typical in an engineering, in a high-tech engineering environment where the design cycles are really fast, right? Typically, these companies put out products every year, and they usually have many different versions of their product, maybe different colors, different functionalities. And this can be quite a challenge from an engineering perspective, right? Because the engineers, while they're designing this, they have to be able to manage all the different data that they have, whether it's design data, simulation data, manufacturing data, or marketing data. All this data has to live and be, they need to be able to access the data and use it, for their purpose. So for today's presentation, we are obviously going to be focused on simulation. And when we look at a product like the BIMI, this handheld projector, which is also wireless, there's three main simulation that I can think, which is not optional, which is 100% a requirement, right? So definitely a CFD analysis to check for heat, dissipating from the chips. We want to make sure that it doesn't overheat. We want to make sure that there's proper airflow and we are placing the ventilations in the right place. Of course, we need to make sure that there is structural analysis done on this product as well, right? Because it's a handheld product, and whenever we have a handheld product, it's not a question about if it's going to drop, it's a question about when it's going to drop, right? Personally, I drop everything, my cell phone, my mouse, anything that's wireless that I can hold in my hand, I drop it. So, the manufacturers have to test for these scenarios because typically these products come with a warranty, right? So they want to make sure that the product will be able to last. If not, it can become a warranty nightmare. If it breaks, easily, and customers are returning their products during that warranty time frame, it can really cut into their profit margin. So we want to make sure that we're testing it in all these different possible scenarios for these products. And then of course, being that this is wireless, it's Bluetooth, right? There's electromagnetics concerns, whether it's interference or even for health reasons, right? Being too close to someone. And this typically involves the electrical engineers running these types of analysis, the electromagnetic simulation. Now, what's really nice about the solution that we have is on the 3D Experience platform, you can run all of this simulation by using the same data. So, when we start our design, we typically started in SolidWorks, right? So where SolidWorks is where we turn ideas into into real products. And then we can take that same 3D model and send it to the 3D experience platform, where that data will reside, and that same data can be used for the CFD analysis, the structural analysis, the electromagnetics analysis, and any design changes can also be very easily handled and pushed to all the different teams that are handling these simulations. So that makes data management on the platform, whether it's design data management or simulation data management, very, very easy to handle.
Sashi, sorry to interrupt. What about our PDM users? How could you elaborate a little bit more for some of them?
Yeah, no, Julio, that's a really good question, right? Because like I said, all these designs typically start in SolidWorks, right? And a lot of our customers today are using SolidWorks PDM to ensure revision control and making sure that there's no duplicate models. So the way we work with SolidWorks PDM is their PDM workflow doesn't really change from what they have today, right? Because what happens essentially is when we save the model and transfer it to the 3D Experience platform, it doesn't actually change any of the local data that's checked out from PDM, right? So let's say we open up the model in 3D Experience platform, we run the simulation, and then depending on the results, we decide to make a design change. So we go back into SolidWorks, we can make that design change, and then we can push that design change to the platform, and then they can then proceed to check in the new design change as a new iteration on their SolidWorks PDM. So the SolidWorks PDM workflow doesn't change; it remains the same. So they can still get that full benefit that they're getting from SolidWorks PDM today.
Wow, that's really awesome. That's really awesome. Exciting. Thank you.
It is really good, and because all of this technology is built for SolidWorks users, we want to make sure that they can get the benefit and from both sides, right, from the SolidWorks as well as the platform. So today, Julio, I'm actually going to start off with our CFD analysis, and the reason why is because, right, when we think about a product like this, it can be a very, very strong product, right? It can be a product that I throw on the wall or I throw on the ground, it never breaks, right? It can be a product that doesn't has really good coverage, really good antenna coverage. But let's say I turn it on the first time and it overheats and it melts all the PCB chips, or it short circuits. Then it doesn't matter how strong the product is, right? It's just the product has to work. So I think the first analysis that we have to run here is to ensure that the technology works, and it works at a steady temperature, so that it doesn't overheat. All right. Awesome. So on the platform, we have what we call, for a CFD solution, we have our fluid dynamics engineer role. So all of our products on the platform are called roles. And the reason why is because we believe that the tools, the functionality that encompasses the product should match your role, right? So sometimes engineers might have multiple roles, right? So they might have the fluid dynamics engineer role as well as a structural engineer role, right? In that case, then they would get those two roles on the platform to be able to perform, the typical responsibilities of that role. So for us, it feels more fitting, calling the solution a role, right? So our fluid dynamics engineer role is a CAD and PLM embedded CFD for flow and thermal performance simulation, accelerating product innovation in a collaborative cloud environment. So when we take a look at this solution for the BIMI, a thermal engineer would typically want to identify the component temperature as well as the airflow circulation revolving around that PCB board, right? Because that PCB board is probably going to be dissipating the most amount of heat. And in this case, we can actually see that heat sink there, and that heat sink is going to be sitting on the main chip of this PCB board, which essentially powers the entire BIMI. So we want to make sure that main chip is at an is at an acceptable temperature throughout its usage. So taking a look at our fluid dynamics engineer role, beyond just running a component temperature or airflow temperature as we just saw, it enables a solution and features and capabilities for many different CFD applications. So from a thermal perspective, we cover all the different heat transfers, conduction, convection, as well as radiation, which is surface-to-surface radiation as well as solar radiation. In terms of modeling, we do multiple reference frames, fans, baffles, porous medias, electronic component models, as well as joule heating, and as well as mapping to structural roles for thermal stresses, right? And I cannot stress this enough. That when you're running an analysis like this, where there is heat involved, you typically want to also run a thermal stress analysis, right? So this is either done by the thermal engineer or the stress and the structural engineer. And again, being that all of this data is already on the platform, we can actually use or reuse the CFD analysis results to run that thermal stress analysis. So so having all that data within that same environment, makes it a single source of truth, right? So it's easy for all the different teams to share that data and run the appropriate analysis that they, depending on their roles. For the flow perspective, we can do steady and unsteady, incompressible and compressible, as well as Newtonian and non-Newtonian, right? So when we think about being able to run things like compressible flows, this is a really good fit for aerospace, automotive. So when we think about CFD, I think that any type of application that requires a CFD analysis, this role would be a good fit. Now, Julio, being that most of our audience today are probably SolidWorks users, I wanted to, right off the bat, introduce the 3D experience simulation workflow for SolidWorks users, right? How do you go from SolidWorks to the platform to set up and run your simulation? And then how do you then go ahead and perform any design changes and push that design change to the platform, right? So let's take a look in close depth what that workflow looks like. So we're going to first focus on the first 4 steps, right? So we're going to start in SolidWorks, we're going to transfer the model to the platform, and then we're going to set up the simulation on the platform. So what we have here is the BME model in SolidWorks, and you can see here we have all the components, right? So it includes the PCB board, it includes the top and bottom casing, it includes the main chassis, the speaker, everything that the batteries, or everything that is required is here. So we're going to actually transfer this entire model. Although maybe the CFD analysis only needs certain components, or the structural analysis only needs certain components, but that's okay. Once all the data is on the platform, the engineer that's running the simulation on the platform can pick and choose what data they want to keep for that simulation. So now, right from SolidWorks itself, we can navigate to the 3D experience add-in right from the task pane. And when we right-click that top-level assembly, we can actually save that data. So you can actually see the status right now. It shows a yellow symbol. That essentially means that the data is not transferred or not saved on the platform yet. So as soon as you turn on this 3D experience add-in, it automatically detects what data you have in your 3D experience platform versus what data you have in SolidWorks, and it creates that link. So so these types of indicators make it so easy for the users to know if, hey, the data is already on the platform or not. And if it's already on the platform, we don't have to duplicate the data and what revisions on the platform and all of that. So it makes, it makes that data management super easy. So I'm going to go ahead and just save this data to the platform. And you can see that as soon as it's saved to the platform, the status will change and it will kind of give me that green check mark. So now that the data is already saved to the platform, again, right from SolidWorks, right within that 3D experience add-in, I can choose the app within the Fluid Dynamics Engineer role to launch the 3D experience platform to be able to set up the simulation. So if in this case, it's going to be called the Fluid Scenario Creation app. So when I click on the Fluid Scenario Creation app, it says launching the Fluid Scenario Creation. It actually launches the 3D experience platform interface. And now in this interface, I can actually go ahead and set up my simulation. Now, for us, when we were creating this software, we wanted to make sure that the software felt and the usability felt more like SolidWorks. So we wanted to make sure that it was easy and intuitive like SolidWorks. So one tool that we have in the 3D Experience platform for simulation is our assistant tool. And this assistant tool can be used by beginners who are new to CFD analysis or even advanced users. And you can see the assistant tool essentially walks you through setting up the simulation. So first off, we can go into the model and we can specify our fluid domains. We can specify our any ventilation holes that we have. Any perforations that we have in the model can be specified. What materials we have in the model can also be specified here. The next step here is we can specify what type of simulation, right? For this CFD solver, we can do steady state or transient as well. So in this case, we'll just do a steady state because we want to see what that max temperature is going to be when we are running this beamy projector. So as we go down this assistant tool, you can actually see that we are getting some green check marks. Now, for me, I love this tool because, although I would consider myself a more advanced user because I use this tool a lot, I still use the assistant tool because this enables me to, I'm confident that I'm specifying all the minimum, all the requirements, all the minimal requirements to be able to run this analysis. So I don't have to, remember if I have set up certain things in the model, have I not, that goes into the simulation. The tool helps me hit all those critical steps to set up the simulation. So we can see here that we've already set up the material, the initial conditions, the boundaries, the zone, the loads, the contact conditions. All of that have already been input into the simulation. So the next step is to mesh the model, and then we can actually execute and run it. So here I'm going to go ahead and mesh. And I wanted to spend a little bit of time to talk about the meshing capabilities on the platform. So we do have quite a bit of meshing tools to be able to do, very, very intuitive and as well as complex meshing scenarios to give you very, very accurate results. So for this simulation, the focus is going to be on that heat sink, right? So we want to make sure that heat sink and the chip underneath that heat sink is at an acceptable temperature. So using some of the very, very intuitive selection tools that we have on the platform, we can actually very easily select the heat sink as well as the area around the heat sink to apply a very, very dense mesh around there. So that gives us very, very accurate results. Now, the open areas within this beamy enclosure, we might not need a very, very dense mesh, and we could probably have a much coarser mesh, right? Well, the meshing tools enables us to very, very easily specify all these different meshing criteria, and we can even mix and mix different meshing as well. So here we have hex mesh, hex dominant mesh, and then we also have a tetrahedral mesh. And these types of techniques enables us to solve the simulation much faster while still giving us very, very accurate results. All right. So now that we have set up the simulation, we are ready to execute the simulation, and then we can post-process the results, right, to see what the results look like, and then make any design changes depending on the results. So let's actually take a look at how we can go ahead and execute this simulation. Now, because this solution, this 3D experience platform, as well as the Fluid Engineer role, is a cloud-capable solution, it is accessible, affordable, and very secure. It also enables us, or enables the users, to tap into high power computing, right? So this is something that we've never had before in the SolidWorks environment, but we do today, right? So high power computing enables users to use hundreds and hundreds of cores on the cloud to run and solve their simulations super fast. Now, high power computing is not necessary for all simulation. It really is a good fit for very, very complex and large simulations. Now, other options we have is also the ability to use local embedded compute. So for users that have 8 cores on their computers, up to 16 cores, they can actually use all of those cores on their local machine without having to pay anything extra. So this is actually almost unheard of in the industry, with even other softwares on the market. We enable our users to use up to 16 cores on their local machine and on the cloud for free to solve their simulation analysis. And of course, being that if the user chooses to solve on the cloud, right, our cloud is ensured very secure. It's a very secure DS cloud environment.
Sasi, I wanted to speak about this here really quick, because many of our customers, they feel very secure, right, just using local servers or just their local network, and many of them could actually be working under certain contracts that needs to make sure that you're working under a very safe and secure environment. So could you talk a little bit more about how data security in the Dassault Systems and under this platform would work?
That's, again, really good question, Julio, and this definitely does come up quite a bit, right? So, first of all of our cloud infrastructure is 100% DS cloud infrastructure, right? So we don't depend on any other third-party companies. So we don't have, anything, all the security, it doesn't have to go 2 ways. It's only one way, is within DS itself. So that's the first thing we want to put out there. The second thing is that sometime around 2019, ITAR actually approved cloud, the ability to do cloud data, and we met all the all the requirements that were put out for the ITAR compliance. Now, to add on to that, right? So cloud has clearly become a pretty big, right, in the software industry, and as we can see, it's growing exponentially. So as cloud software has been growing in the market, there are companies out there that are basically policing the security of your data. So Dassault Systems has made a commitment to make sure that we have the highest level of security that is available on the market today. So we do have a set of certificates that show how secure our data is. So if any of our audience today that is interested to learn more, please reach out to us, and we will be more than happy to share all that certificates with you.
Awesome. Thank you very much for sharing. So we could rest assured that the data would be secure.
Absolutely, all the data will be secure. So one more thing I would like to add, only the CAD data will be on the cloud. So if a user decides to run a simulation, when the simulation is solving, like I said, they can solve it on their local compute, and they can also save the data locally as well. So there are options, you know, if the user would like a more hybrid environment where maybe some of the data is on the cloud and some of the data is local, they also have the option to do that. All right, so let's take a look at the results here. So, you know, you can, right off the bat, you can see how nice the result looks, right? I mean, it's so so clean, very sleek, right? Because all of this technology is really brand new. It's only been available for the last few years. So we've incorporated, you know, the technology wise to ensure that, you know, the user is getting, you know, really good result feedback, being able to zoom in, being able to extract, you know, critical graphs that show what your results are. So in this case, we actually are extracting the maximum temperature of the chip, the main chip, as well as the heatsink as well, right? Now the problem is when we took a look at the results, they're pretty high. The temperature, you know, I think that heatsinks that chip is at 130 Celsius, and our goal is to be under 80 Celsius, right? So this is a very common environment, engineering environment, right, where you design the product, you run your simulation, and then you identify the problems, and then you enable design changes to fix the problem. That's what, you know, that's really what that engineering iteration or product development cycle would typically look like. So in this case, that brings us to the last 4 steps, right? So, you know, we would typically now go back into SolidWorks, make a design change to get better results, and then we can actually, in this case, rerun the same analysis that we already set up before, to get updated results, and then we can see if our design changes make sense, right? So this is a iterative process, right? So we typically go through this process a few times to get to the best design. Now the advantage here is that, right, by getting to the best design during this stage, when you get your physical prototype, it shortens the physical prototyping stage, right? Because, you know, typically in the physical prototyping stage, it becomes more of a confirmation when you're running that physical prototype. So you have less prototypes. It's, you know, you pass those tests much quicker, and then you can move on to the manufacturing stage.
Awesome. And what under this workflow, Sashi, so technically you go back to SolidWorks, you make those design changes, and then it seems here under step 8 that you save them through the experience, and you can just rerun the simulation, right? Is that how it is?
Yes, exactly. So we're actually going to take a closer look at that, where, you know, we make the design change, we save it to the platform, and we can even revision it, right? So we can revision all our changes, and then once we are on the platform, we have several options. We can either rerun the analysis that we already set up before in step 4 and step 5. We can create a copy of that simulation that we did in step 4 and step 5, and then rerun and then run the simulation. And guess what? Then we have 2 versions, for the old version and the new version, and we can also compare the results, which is what we're going to actually do in this case. So let's take a look at what that looks like. So right here, we are back in SolidWorks. So we are actually in revision D1 now, right? So in this case, I'm not going to make any design changes specifically, but I'm going to add a fan, right? So that's considered a design change. In my opinion, right, when you're adding a component like this to the assembly, that calls for a new revision. So in this case, we have revision. We're going from revision D to revision E to the platform. And what's great about having this type of revision on the platform, right? So think about that engineering team again, right? That we discussed a few slides ago, where we have the thermal engineers, we have the structural engineers, we have the electrical engineers, we have the design engineers. You know, maybe we have the technical sales engineers. We have all these different engineers that are working together on this platform. As soon as you push this new revision, they will all get that notification that there is a new revision for this model, right? So let's say if they're all in that 3D Swim community, which is another tool that we have on the platform, where all the different stakeholders for this project can collaborate, can talk to each other, can post images and share models. Let's say the designer makes the change and goes to the 3D Swim community and say, hey, we have a new revision for the BME model. Please run all your ongoing simulations and future simulations on the new revision. Now, this is what I'm talking about in terms of collaboration, right? We don't have to depend on emails. Imagine if someone didn't check their email and they're running simulations on the old model. That's a waste of time, right? Because now we have a new model, right? We have made a change. So these types of things is what's happening today. So being able to collaborate in on the 3D Experience platform, to me is really going to push that innovation to the next level, especially if we include simulation in that.
That's a very big impact. I can just think of like how many times you go through, like you're trying to look for an exchange, right? A conversation exchange with a colleague, and then you have to go through your bunch of different emails. Like visibility here, the amount of visibility that it adds, right? Just going through 3D Swim and seeing everything at any time, right? Just at real time. That's huge. That's huge. I definitely like that.
Yeah, I mean, it essentially takes collaboration to the next level. That's for sure, right? Everything is accounted for. Everything is out in the it's out in the open. There's no hidden emails or forgotten PDFs. Everything is there. All right. So taking a look at the results, we can see here we can make a comparison of our old model versus our new model, where we added the fan. And really what the fan is doing here, as you can see, is just diverting the airflow in the right direction. Is ensuring that the airflow is going over that heat sink, right? So that heat sink is pulling all the hot air from the chip, right? So that's conduction. And then the cold air going over the chip or going over the heat sink is pulling all the hot air out of the heat sink. So that's convection. And then as the hot air blows out from the other ventilation holes, right? So that pushes out the hot air, right? So now we can actually see the result is much better, right? So we brought the chip temperature from 130 down to 74 Celsius, right? So now we are actually within the temperature range that we want to be, right? So we wanted to be under 80 and we're at 74. And the heat sink, we can see it's at 41 Celsius. That's actually a few degrees higher than room temperature. So the results actually make sense here because the air that's blowing over the heat sink would probably be at the room temperature. So so this is exactly the type of results that we were looking for. All right, so now that we've covered the CFD analysis, we know that it's going to work, we know that it's not going to overheat. Now we can take a look at our structural analysis. So from a structural analysis perspective, we have on the platform a proven, robust, and reliable FEA solution, which uses the ABACUS solvers, right? So ABACUS is a software that has been around for 20 plus, almost 30 years. And it's really what kicked off the SIMULIA brand under Dassault Systems. It is one of the best, if not the best, structural analysis software on the market today. And what we've done is we've taken that ABACUS solver and we've integrated it into the 3D Experience platform, enabling SolidWorks users to be able to use this very, very, advanced, great simulation solver. So on the platform, we actually have multiple roles for structural analysis, unlike our CFD solution where we only had one role. So here we have, like I said before, roles that suit your your responsibility in the engineering team, right? So our first role we have is, our structural designer role. So it enables linear static analysis, frequency, buckling, and thermal. So these are the types of analysis you would typically run in the early design stages, right? So just being able to, run design run simulation to check your design, check different features, and make design changes based on these results, we essentially call that simulation-driven design, right? So this is a really good entry-level simulation role for anyone that wants to integrate simulation into the design process. One step above that is we have our structural engineer, which includes all the features from structural designer, but also includes our linear dynamics capability. So being able to run vibration analysis, right? So so this is not a requirement for everyone, right? It really depends on your type of application you have. But again, so if you need a vibration analysis and most of your simulation is in that linear static space, then this structural engineers is a really good fit. Now, one level up is our durability and performance engineer. So this enables our users to run nonlinear analysis. So whether it's nonlinear materials or nonlinear conditions, this will be a really good fit. And this durability and performance engineer role also comes with fatigue analysis. So if you want to check, if your part's going to fatigue after multiple cycles, we have that ability as well. One level up from our performance engineer is our durability and mechanics engineer role. So this role includes a nonlinear dynamics. So if you have moving components, this structural mechanics engineer role has an explicit solver, which makes the nonlinear dynamics much easier to solve and converge. So we make very, very complex simulation easier to solve, enabling our users to get very, very good results. In addition to that, it also has a material calibration tool. So if you want to calibrate some stress strain curves, maybe from running your own tensile test, you can. It has advanced meshing capabilities, advanced contact conditions, as well as some geometry prep tools, right? So sometimes for simulation, you might want to make some slight design changes to your model to simplify the model for simulation. You can do that right in the platform with this role. Now, just one more thing I wanted to add. These last two roles comes in two versions, one with the fatigue analysis and one without the fatigue analysis, right? So we understand that some users might not need fatigue analysis, so we also have that option. So essentially, we have 6 roles here to meet your needs. So whatever it is that you're doing with the FEA analysis, we have a solution for it. So let's take a look at running a structural analysis for the BME model. And in this case, we're going to run it on the main base or the chassis of the BME, right? Because this is essentially where all the strength is going to reside in this assembly. So this is a very, very typical analysis that that is done for handheld devices. Just to make sure that if the product is bent, it is bent for normal wear and tear versus abuse, right? So they tested to see that, hey, at which point the product will actually bend to the point that it no longer works. So that's usually the cutoff of the warranty, right? So that's kind of how they protect themselves in terms of warranty. And that's okay, right? So even if you take your smartphone today, if you bend your smartphone a little bit, it's probably still works. But if you bend it a lot, right? If you purposely abuse it and then it bends and maybe it breaks something inside and it stops working, that actually voids the warranty, because the manufacturer can say that, hey, I've done the 3-point bending test and it will require a lot of force to bend it like this, which means that this is not a normal wear and tear. It's not like you put it in your back pocket and it bends. This is you actually try to bend it purposefully, so that's considered product abuse. So here, what we have here is we're going to run the test with a material, with an acrylic material. It's a bilinear material, so it's not a linear material. And we're going to push this rod down the middle, and we have 2 fixed rods on each end. Now, the structural, being that this is a non-linear material, we're going to use the structural performance engineer to run this analysis. So this is how the product will look like in the 3D Experience platform. And one thing I wanted to bring up right away is how it looks. It looks exactly like our CFD solution, our fluid dynamics engineer, right? So for us, we've made a commitment to create these solutions, whether it's CFD or FEA, to make sure it looks the same. Because a lot of times, right, maybe in smaller engineering teams, you have the same person running the CFD analysis that's running the FEA analysis. So rather than having to go learn a new tool or two different tools, they can actually just very, very quickly learn one tool and be able to run all the simulations they need, right? So what we have here to the left of the screen is the history tree. On the bottom of the screen, we have our action bar where we have all our icons. And just like before, to the right of the screen, we have our assistant tools. The assistant tool comes with both the FEA solver and the CFD solver. So again, any user today that's using simulation or new to simulation or even using SolidWorks simulation will be able to jump into this simulation on the 3D Experience platform right away. So let's take a look at our results here. So this is our displacement results. So what we are seeing actually is, as we displace or as we deform this plastic part, it actually snaps back into its original shape, right? So what this tells me is that, let's say if I took this BME and it's a portable device, so maybe it's in my backpack or, I'm moving it around and whatever it is, it allows for some deformation and it still returns to its original shape, right? It has that nice sleek curve shape. So I'm not too concerned if it actually deforms a little bit, because it will not really affect the component or won't affect the look of it. And we can also see from a stress perspective, right? We want to make sure that we are not stressing the plastic. We can actually see what that looks like. Now, one thing, Julio, I wanted to bring up is that we tried to run this in SolidWorks simulation before we ran it on the platform. Now, SolidWorks simulation, it was actually very difficult to solve a simulation like this. Now, SolidWorks simulation does have a nonlinear solver, and it is a really good fit for a lot of applications. But a simulation like this, where we have a nonlinear, it's a bilinear material, which has some snapback effect. It actually was a struggle to solve it in SolidWorks simulation. We were actually able to solve this very, very easily on the platform because, and primarily because of how it handles contact conditions, right? So that bar that's pushing down the middle, as it comes in contact with the plastic, we didn't really have to specify any contact conditions. This software, using the ABACUS solver, automatically takes care of contact conditions. So we don't have to go there and specify that it's that it's a separate material and separate surfaces. It takes care of all of that automatically, and it enables us to solve these types of complex simulation very easily. Now, moving forward from the 3-point bending task, we also have to run the drop test, right? So going back to my earlier example, anytime you have a handheld device, it is going to drop. It's not a question about when, it's if it's going to, not a question about if, it's a question about when it's going to drop. So here, we can take a look at this result. So this is a drop test on one of the earlier models of the BME, right? So you can actually see that the body is a little bit more chunky, right? There's a little bit more material in there. So after running some of the simulation analysis, we actually were able to come to realize that we might have over designed it a little bit, right? So we were able to remove some material and make it lighter, right? So it makes it more easier to transport, this handheld device. With the platform, we also have some really cutting edge post processing for results. So you saw some of the animation on the CFD side. So in addition to that, we're also able to do some section views. We also are able to click through different iterations. So you see the different frames, so we can actually capture at which point during that drop that it induced the most amount of stress on the component. And with this component, we have very thin walls. You can also see the stress across the thickness as well, which is something we cannot do with prototype testing. So this is something that we can do here in that virtual simulated environment. Now, of course, we can run our simulation analysis, the drop test analysis for all different angles, different heights, and being that this is again a cloud solution, you can run all of this analysis in parallel, right? So let's say with the drop test, you want to run it for all different corners, a straight drop, a backdrop, and you want to test it for different heights. So now we're talking about maybe 10 different analysis. You can actually send 10 separate analysis to solve. Let's say at the end of the day, when you're done working for the day, you can send the you can execute the simulation. You can go home. You come back the next day. You have 10 simulation ready to go, and then you can compare your results, right? So so being able to run all these analysis in parallel is a huge time saver.
Sasi, do you send them to the cloud?
Yes. So if you want to run the simulation in parallel, you have to send it to the cloud. So if you want to solve it locally, then you would have to solve it at one at a time, because it uses your local hardware to solve the simulation, right? So your local hardware on your computer typically can only handle one simulation at a time. But being that the cloud can parallelize all the simulation, side by side or back to back or in series, you can solve multiple simulations on the cloud. And this is really why cloud simulation is I think that's going to be the future for simulation. So we are seeing a lot of companies already taking that leap and going in that direction, and I think that's the future. So so we are hoping that a lot of our customers will also kind of see that that's where the technology is going, that's where the industry is going, and the earlier they get into it, I think the better.
Yeah, it takes away the restriction, right, of your local resources, or having to spend additional money and having to buy a high-end computer. I mean, my computer would probably burn if you run more than 2.
Yeah,
so
I agree. Exactly.
That's really
That's
awesome.
a really good point that you brought up, is keeping up with desktop technology and hardware, right? So cloud kind of takes that out of the equation, and over a few years, there's a huge savings, right? Not having to keep up with hardware. Yeah, that's again another benefit to the platform. All right, so with that said, I'm actually going to wrap up the structural analysis, and we're going to move to our last piece of the puzzle, which is the electromagnetics simulation using our electromagnetics engineer role. So for this role, we offer a high-performance 3D electromagnetic simulation powered by the industry-proven CSC Studio Suite technology on the 3D Experience platform. So for those of you on this presentation today that are running any type of electromagnetic simulation, I'm sure you are familiar with CST. It really is one of the industry leading electromagnetic simulation solvers, and you might know that CST is today owned by Dassault Systems. So a lot of many large electronic companies already use CSC Studio Suite today, so it is really proven. And what we've done is we've actually taken our CSC Studio Suite and we've connected it to the platform. So it's a little bit different than the other two solutions that we just saw. So you can continue to use CSC Studio Suite just the way it is today, but because it's connected to the platform, you can then harness the data management that we provide. So the same data that you use for the FEA and CFD analysis, you can use it on the platform itself, right? So from a solution perspective, our like I said, it is 100% CSC Studio Suite. So it enables high frequency and low frequency electromagnetic simulation, and that's a big differentiator for us, a big advantage compared to some of the other software in the market that breaks up high frequency and low frequency. We provide all this, both high and low, within the same solution. We can optimize antenna and microwave devices. We can run this simulation to prevent and minimize electromagnetic interference, which is going to be big for this BME model, as well as electromagnetic compatibility issues. And our solution here also enables coupled simulation at a system level, hybrid, as well as multi-physics, right? So, if you want to capture some heat due to electromagnetics, you can also do that with this solution, as well as heat transfer. So there is some overlapping features here with our CFD solution as well. Now, because this solution is connected to the platform, it has easy access to SolidWorks, right? So if you have your model in SolidWorks, you transfer it to the platform, and then from the platform, you can open it up right into CSC Studio Suite. And just like what we talked about with the other two solutions, it enables collaboration, version control, knowledge capture. It has a lightweight visualization on a web browser, right? So once you have run your simulation in the 3D Experience platform interface, and let's say you want to share your results, those results can actually be viewed directly on a web browser. So if you have a phone, if you have an iPad, you can even start viewing your results on those. We also provide a trade-off analysis for our electromagnetic simulation, as well as our CFD and FEA solutions, where it allows decision makers to choose the best design based on all these different data inputs. So so this is along the lines of parametric optimization. And then, of course, future scalability to other 3D Experience roles. So, we are, as you can see, making a huge commitment to our 3D Experience solution, and we're going to continue to develop more and more capabilities on the platform. And as we develop this, we're also developing a connection between all our different roles on the platform. All right, so taking a look at how we can launch our CSC Studio Suite from the platform. So we can click on that CSC Studio Suite app, and you can see that it actually opens up CSC Studio Suite. So, CSC Studio Suite on its own has a very, very nice interface. So we didn't integrate it into the platform yet. It's just still its own platform. But you can see that on the top, it says connected to the 3D Experience platform. So we can actually open up that data directly from the platform. So here's a simulation that we ran. It's a far field simulation on the BME model for the 2.4 gigahertz frequency. And we can take a look at what that looks like. And as I said, it's a very, very clean and easy to use interface. And this, again, is the same data set that we use for our structural analysis, and the same data set that we use for our CFD analysis. So there's no duplication of data here. Here's an example of our electric field magnitude at 65 gigahertz. So this would be considered a very, very heavy simulation, right? Because we ran it on the entire model. And just like our other solutions, we provide our users options to run it, whether it's local compute, on the cloud, and all these different capabilities as well. And then what about future concepts, right? And that's really another huge benefit of running simulation, right? Not just for electromagnetics, but also for FE and CFD, right? So let's say you have a version out in the market today, and you're starting to work on a future concept and trying to figure out what if scenarios, right? So here's a BME model, right? So the original model only had one antenna on one of the sides, right? So maybe there was some problems with coverage, and we can even test out 4 antennas, right? 4 smaller antennas on both sides, and to see whether it provides better coverage. These are the types of things that we can do with simulation. All right, with that said, some next steps here for our audience to learn more about all the functionality, tools, roles that you saw today. You can go to www.solidworks.com/simulation. You can also go to my.solidworks.com and you can sign up for a free account. And then once you log in, you can just search for SIMULIA and you will find, all sorts of videos, blogs, white papers, really, really in-depth information on all of the technology that you saw today. So I wanted to wrap up today's presentation with some values, right, that we get out of running the simulation on the 3D Experience platform, right? So, with a product like the Beamy, we can deliver delightful consumer experience. Of course, the goal is to reduce product development costs. We can innovate a broader portfolio with all the different what-if scenarios and using our trade-off analysis. We can minimize rework and compliance costs, right? So that's huge, especially in the prototyping stage. And then, of course, streamlining communication between stakeholders. And remember, with the platform, it's not just simulation. It's from inception all the way to the final product, right? So it's design engineers, electrical engineers, manufacturing engineers, marketing team, your sales team, your strategy team, your operations team, right? Your supply chain team. All of these different teams can actually work together in that cohesive environment on the platform and share data and really push your innovation to the next level. With that said, I wanted to thank everybody. I wanted to thank Design Point for inviting me to present today at this More is Possible event. And I wanted to thank my host, Julio, for the great questions. So yeah, thank you very much.
Sasi, thank you so much for presenting today. That was really awesome. That was a really great presentation. So many takeaways for myself, and I'm sure for the customers. And I'm sure you guys are gonna have some questions. So hold them, write them down, and then we'll have some time to help you answer those. So thank you once again, Sasi, for this great presentation. And yeah, guys, see you soon.